perfect papers. Okay, so now we go into the shop and we see that Yummy Chocs are on sale. And in week 1 we get 20% off. So let's say that the box of Yummy Chocs costs X kronas from the start, from the beginning, originally. So what are the box of chocolates going to cost when we had 20% of discount? That means that we would pay 80% of the original. We know that the factor change of 80% is 0.8 of X. So after the first week's discount, we would pay 0.8 of X. We get 20% off. Then after week 3, we get 50% of the sale price. So that means we'd have our 0.8x, which is the original price, and we'd only have to pay half of it. So we divide that by 2. So the amount that we would pay after week 3 would be 0.4x, which we know is 40% of the original price. So after week 3, that we pay 40% as of the original price, we know that the discount then must be 100 minus 40. So the discounted percentage is 100 minus the 40% that we would have paid, which is 60%. So the rate of the discount that I think it asks you for in this question was with how many percent has the price of the chocolate box been reduced from the original price? So 60%. Then we had this fun question, which we have 2 girls, and they're both eating a chocolate bar, but they're eating a different weight of chocolate bar, probably different make. And what do we know? We know that Anna and Sophia. So we have Sophia. She eats 1/3 of her bar, whereas Anna eats 2/5 of her bar. Let's call the weight of Sophia's bar X grams. She's eating a chocolate bar that weighs X grams, whereas Anna is eating a chocolate bar, weight of Anna's bar, let's call it Y grams. Okay? So what do we know? Well, we know that when they both eat the same weight of chocolate, so that's the key here. They eat the same weight. So that must mean that 1/3 of her bar of chocolate, X divided by 3, must be the same as 2/5 of Sophia's bar, which is Y. And the question is, whose bar of chocolate is biggest? Well, when you set it up like this, it's really easy. Because if you multiply both sides of the equation by 3 to get rid of the divide by 3 here, so times both by 3, you get X over 3 multiplied by 3 equals 2/5 of Y, also multiplied by 3. 3 divided by 3 is 1, so on this side you just get X. And on the other side, 2 times 3 is 6. 6Y divided by 5. So what do we know about her bar of chocolate? Sophia's bar is being X, but it's 1.2 lots of Y. So if her bar is X grams, it's 1.2 times 20% larger than Anna's bar. So now we know that X, 6 divided by 5 is 1.2. 1.2 lots of Y. X is 1.2 larger than what Y is. So that's one way of doing it. Another way of doing this question is, let's take an easy number. Do you get this one, the algebra way? It's actually quite easy. set up your equation like that, manipulate both sides, you get 6/5 of y. But another way, and it would give you almost as many points, if not exactly the same points, let's say that instead of x, let's take an easy number that divides by 3 that's reasonable for a bar of chocolate. For example, 150 grams. We don't know what hers weighs yet, but we know that 150 grams divided by 3 would mean that Sophia would eat 50 grams of chocolate. Yeah? So if Sophia eats 50 grams of chocolates, that must mean that 2/5 of Anna's bar, 2/5 of y, must equal 50 grams because they eat the same amount of chocolate. So now we can work out what y is by just manipulating that. So we can say that 2/5 multiply, it's the same thing as what's already there. 2/5 of y, multiply both sides by 5/2. So, I'm doing the same thing to both sides. I'm multiplying both sides by 5/2. Why? Because 5 divided by 5 gives me 1. 2 divided by 2 gives me 1. It gives me y by itself now. So y equals 50 times 5 divided by 2. 50 divided by 2 is 25. 25 times 5, 125 grams. So I now have an actual weight for Anna's bar. So Anna's bar, we know now, weighs 125 grams. We knew that Sophia's weighed 150. We decided that. So we again get that Sophia has the largest bar from the beginning. Another way of doing that, because there's many ways to do this one, is to think that, okay, we know that x/3 has to equal 2/5 of y. Here we have two fractions that have different denominators. We can never compare fractions that have different denominators. So we have to change them to the same denominator. We multiply the x side by 5, the denominator down here, and the y side by 3, which is the denominator down here. We then get 5x/15 equals 6y/15. So 5/15 of x equals 6/15 of y. So that they're eating the same amount of chocolate. She only needs to eat 5/15 of her bar of chocolate in this one to get 50 grams, or whatever it is. But here she'd need to eat 6/15. So again, this is showing you, as long as you understand that the smaller fraction here is resulting in the larger chocolate bar, because she's eating less chocolate to get the same amount as she is eating. So 5/15 of a big bar of chocolate is giving her the same amount of chocolate as 6/15 of a smaller bar of chocolate. So there's a few different ways, and you can choose whichever way you feel suits your way of thinking best. I'm sure there's even more for that one, but they were the ones we came up with. Now we have 2 hearts, also made out of chocolate. It makes you extremely hungry. What do we know? We know that the dimension of this one is 10 centimeters high, and the height of this one is 5 centimeters. They don't tell us the length dimension at all, but they do tell us that these are similar hearts, okay? So that they have the same shape in every other way and the same thickness. And what do we know about these hearts? Well, if we have 100 grams of chocolate and put them in the form at the same thickness, we'd get 8 small hearts. And the question is, a small heart costs 5 kronas. What is the kilo price of small hearts? Well, the first thing we need to work out is what's the weight of a small heart. If 100 grams is enough for 8 hearts, then we need to work out the weight of one heart is 100 grams divided by the number of hearts we can make, which is 8, which is 8 into 10, 1, 2 left over, 8 into 22, and 4 left over, so 12.5 grams. So one heart weighs 12.5 grams. If we're going to get the kilo price, we know that the cost per kilo equals the cost divided by the weight in kilos. So let's change this weight already directly to kilos. That's the same as 0.0125 kilos. Divide grams by 1,000 to get kilograms. The cost of the heart was 5 kroner, so we have 5 divided by 0.0125, which will give us 400 kronas per kilo. If you're not familiar with this formula, which I think, it saves a lot of time, you can go from 12.5 grams costs 5 kronas. Go from that to divide both sides by 12.5 grams to get what 1 gram costs. It equals 5 divided by 12.5. And then to go from 1 gram to 1,000 grams, we'd multiply by 1,000, which would give us a cost of 5 divided by 12.5 times 1,000. And you'll get exactly the same answer, 400 kronas per kilo. So there's 2 different ways there. I think if you convert the weight directly to kilos and just divide the cost by the weight in kilos, you get the answer directly. Saves you doing all of these steps if you're starting to run out of time. So this is a useful formula to remember. Price divided by the weight in kilos, or the volume in litres already directly, will help you there, speed you up. Okay, that was the first bit of the question. The second bit was seeing if you understand what happens to the scale when you increase the length dimension. We can see here that we've doubled the length dimension, which means that we would also double the breadth dimension. So a double length and a double breadth times double length. Doesn't matter what the area is, it's going to give a 4 times larger area. 2 squared is 4. So we know that if 100 gram is enough for 8 small, it's going to be enough for 8 divided by 4, which is going to be 2 large hearts. So the same amount of chocolate is going to be enough for 2 large hearts. 8 divided by the scale factor, which is 4 times larger, so you get 2 large hearts out of the same amount of chocolate.